guys. So here is Unit 9, Part 2. And the first thing you might see are these varying shades of pink squares. And so what I want to talk about is concentration. So concentration is the amount of solute dissolved in a certain amount of solvent and at a particular temperature. The amount of solute dissolved in certain amount of solvent. Oh, excuse me, words are not making sense. Solvent, okay, at certain temperature. Okay, now what we can see from the pink squares is something, in this case, the solute is the amount of pink, right? Then dilute would have less solute, and something that is concentrated would have more solute dissolved. Excuse me. Would have more solute dissolved. And so this is just kind of a picture representation of concentration. And so one thing we do is we use molarity to help us calculate concentration of exactly how much is dissolved. And so the first way we learn to calculate concentration is through molarity. And molarity has the abbreviation of a capital M, and it's equal to your moles of your solute divided by the total liters of solution. Now remember, your solution is your solute plus your solvent, so it's all kind of concluded. It's the finished product. How much total liters do we have? And so we can use that formula to help us do a lot of things. It's also on the back of your periodic table, so it will be given to you on your midterm on Monday. So the first question, what is the concentration of a solution in molarity that contains 4 moles of NaCl in a 1.5 liter aqueous solution? So key things, they want molarity. We've got 4 moles of NaCl and it's a 1.5 liter solution. So first thing we do is we write down our formula. I know they're looking for molarity, so I say M is equal to moles divided by liters. I'm going to say, okay, what numbers do we have? We don't know M, so I'm just going to rewrite it. We do know our moles. We have 4 moles, and it's divided by our liters, which is 1.5. And so that means our molarity is going to be 4 divided by 1.5, which is going to give us 2.67 M. And so the way you would say that is you would have 2.67 molar. And normally you would also write the fact that it is NaCl there with it. So that was like the basics, finding molarity when you're given moles and liters. But there are multiple variations of it, so let's get into all of the ones I could think of. So how many moles of NaCl? So we know we're looking for moles of NaCl are needed to make 2 liters of a 0.75 molar solution. So again, we know we're using M equals moles divided by liter. So figure out what letters do we have. We know that M, our molarity, is 0.75. We do not know moles, so I'm just going to leave the word moles there. And we do know our liters, which is 2. Now remember, in algebra, if you ever need to solve a problem like this, your goal is to get letters on one side, numbers on the other. And so in order to get the 2 from being on the same side as the word moles, you do the opposite of whatever is happening to it in order to move it across the equal sign. So the fact that moles is being divided by 2 means that if I multiply by 2 on both sides, this will cancel out and I'll have moles is equal to 2 times 0.75, which is equal to 1.5. So I need 1.5 moles, or a correct answer would be 1.5 moles of NaCl specifically. Okay. Now number 3, what is the volume of a 1.7 molar solution containing 3.2 moles of NaCl? Well, again, we're using M is equal to moles divided by liters. I know that M is 1.7, our moles is 3.2, and we do not know liters, so I'm going to leave our liters. Now, in order to get our liters by itself, okay, we could have done this in the previous problem, but we can cross multiply if we set it over 1. And so if we cross multiply, okay, you get 1.7 liters is equal to 3.2. So we just divide by 1.7 on both sides. This cancels out, and your liters are equal to 3.2 divided by 1.7, and that will give you 1.88. So we need 1.88 liters. That's the volume that the solution would have to be if it had 3.2 moles and a concentration of 1.7. If we look at number 4, this one is a little bit different. It's asking for how many grams of NaCl are needed to produce 1.5 liters of a 2.5 molar solution. So again, even though there's grams involved, I'm still just going to write my formula. M is equal to moles divided by liters. I know that M is 2.5. I don't have a number with moles beside it, so I leave it alone. And then liters is 1.5. And so again, if we want grams, but we can only solve for moles right now, so I multiply by 1.5 on both sides, and that will cancel out. And my moles would be equal to 2.5 times 1.5 would give us 3.75 moles. Now, if I have 3.75 moles, I can use a T-chart to change moles of NaCl into grams, right? I just repeat my pattern that I've been learning about, moles of NaCl to grams of NaCl. And I know that to convert from grams to moles, I need my molar mass. So we have Na and Cl. I have one of each. Sodium is 22.99. Chlorine is 35.45. They stay the same when you multiply by 1. And then we just add them all together. And so 22.99 plus 35.45 give you 58.44 grams per mole. So I put 58.44 grams per 1 mole. And so that means our number of grams is 3.75 times 58.44, which gives us a total of, let's see, I need a little more room here, gives us a total of 219.15 grams of NaCl, which is quite a lot of salt. So that was pretty much different because since we were looking for grams, we solved for moles first and then used a T-chart. But let's go ahead and look at the last problem. So the last problem says, what is the concentration? Okay, so they're looking for concentration of a 0.75 liter solution containing 100 grams of NaCl. Now, when you see the word concentration, concentration is measured a couple different ways, but one, since we've been doing molarity this whole video, and since it says liters, that's an indicator that we're going to be looking for M. So if M is equal to moles divided by liters, well, I don't know M, that's what I'm looking for, and I don't know moles either, but I do know liters is 0.75, and I know that since I have 100 grams, I can figure out my moles. So 100 grams of NaCl, I just put it into a T-chart, and we calculated the molar mass to be 58.44 grams of NaCl, and I know that this time it goes on the bottom because I start with grams. And so my pattern repeats, and I put 1 mole of NaCl on the top. And so 100 divided by 58.44 will give us 1.71 moles. So I just plug in that 1.71 there, and M would be equal to 1.71 divided by 0.75, which would give us 2.28 as our final answer. And so hopefully this helps you with molarity and just kind of seeing every type of problem that you could be asked about it. So stay tuned for part 3.